Let's talk about the 6 basic trig ratios or basic trig functions that you get taught in a trigonometry class. I want to go back fundamentally to geometry to show you where these ratios or relationships are derived from, and then we'll talk about the names and things like that. So let's look at this right triangle. Here we have a right triangle. We know it's a right triangle because it contains a right angle. And that means that we have 2 acute angles that are on the other 2 corners of our right triangle. I have labeled one of those angles theta, and I am going to talk about the sides of this triangle in relationship to theta. This side, this bottom part, as I have it drawn here, of this triangle, is the side of the triangle that is adjacent to our angle theta. And here, this side is the side that is opposite in the right triangle to our angle theta. The side that is opposite of the right triangle in any right triangle is always called the hypotenuse. So I'm calling this adjacent, I'm calling this opposite, and I'm calling this hypotenuse. So now that we know the terminology, let's talk about the sine function. The sine, S-I-N, which is shorthand for sine, the sine of theta is the ratio of 2 sides of a right triangle. And it's specifically the 2 sides that are the opposite side and the hypotenuse. So the sine of theta is always the opposite side of the right triangle from the angle theta divided by the hypotenuse. So sine is opposite over hypotenuse. And this is the length of those sides. It's the length of the opposite side over the length of the hypotenuse. And that ratio, whatever that value is equivalent to the sine of that angle theta. So there's the sine function. The cosine of our angle theta, cos is short for cosine. Cosine of our angle theta is the adjacent side to the angle theta in the triangle. Here it's this side, divided by the hypotenuse. Remember, the hypotenuse is always opposite the right angle in the right triangle. You can't talk about having sine, cosine, or tangent of an angle measure unless you are in a right triangle. All right, so there's cosine. Cosine is adjacent over hypotenuse. Again, the length of the sides of those right triangles. Tangent. We write that as tangent. We write the shorthand of tan of theta. And it is, as you can see, the length of the opposite side in the right triangle from our angle theta divided by the length of the adjacent side in our right triangle. So it is opposite over adjacent. So between sine, cosine, and tangent, we use all 3 sides of our right triangle, but remember those sides are in relation to our angle theta. So there's sine, cosine, and tangent. Let's talk about their cofunctions. Sine, cosine, and tangent each have their own cofunction. Their cofunctions, this is cosecant, this is secant, and this is cotangent. And based in the same right triangle, with the same angle theta, with an opposite side to theta, an adjacent side to theta, and a hypotenuse that is directly across from the right angle, here are the relationships for the cosecant of that angle measure theta. It is the hypotenuse, the length of the hypotenuse divided by the length of the opposite side from the angle theta in the right triangle. And these relationships, all 6 of these basic trig relationships, are true no matter how small or how big your right triangle is. We could be talking about the side of a mountain, where here's the mountain peak and here's the ground. If we could go right directly down the middle of the mountain and out to the edge of the mountain and figure out that length and figure out an angle to the horizon, we can talk about these 6 trig functions in that setting. It doesn't matter how small or how big your right triangle is. For secant, which is the cofunction to cosine, the secant of that angle theta is going to be the length of the hypotenuse divided by the length of that adjacent side. And the cotangent of that same angle theta is the length of the adjacent side over the length of the opposite side. Now, look for a relationship. What cofunction relationship exists between sine and cosecant? Do you see any relationship there? How about, is it the same relationship between cosine and secant? And is it the same relationship between tangent and cotangent? So do the 3 big basic trig ratios have the same type of mathematical relationship with their own cofunctions? And the answer is yes. The cofunctions are the reciprocals of the original function. If the sine of theta is opposite over hypotenuse, and we know that a reciprocal relationship is 1 over whatever we're given. Remember, 1 over, let's just go right back to the basics of the algebra of it. Compound fraction, right? Fraction over a fraction, we take the top fraction and multiply it by the reciprocal of the bottom fraction. And lo and behold, what is that? That is the reciprocal of the sine function. That is the cosecant value of that same angle measure theta. So these are all reciprocal relationships. Make sure you know those. Now what I want to do is I want to leave our right triangle with our opposite and our adjacent and our hypotenuse, and I want to bring us into the xy plane. This is where we do the majority of our work in calculus, is we are in the xy plane. And there's things I want you to start looking at when we get into the xy plane that are always going to be there, always constants that we can count on. So here's some things I want us to count on. We know that this is the point of origin. Always, always, for us in calculus, the point 0, 0. We know that any distance that we travel to the right from that point of origin, any horizontal distance, for us is x. Now we don't have to have an x-axis. We could have a t-axis or something, but for right now I'm going to stick with x and y because that's what you're comfortable with. So when we talk about horizontal distances in the xy plane, we know we're dealing with the independent variable. We're dealing with x. So any length whatsoever that we go out here, let's say we go the length of this side of this right triangle from here to here, we're going to call that x. And in the same vein, any vertical distance we call y. We can see that right here. We're going to call that vertical distance y. So this side of this right triangle for us is going to be called y. We know that if we go a horizontal distance out in the plane and a vertical distance out in the plane, wherever we stop at a point. There's the point xy. Why is that the point xy? Because we went a distance of x horizontally and a distance of y vertically. That mapped us to a point in the plane, the point xy. Any straight line distance on a circle from the center of the circle to the surface of the circle, that distance is called the radius. That's where I'm getting r from. We have this imaginary circle in the plane with a radius of r, and you notice the way that I have my right triangle sitting in quadrant 1 in the xy plane, that distance is equivalent to what we have been calling the hypotenuse. So all I've done is change letters on you. I haven't changed anything else. We've gone from O, A, and H. We're now dealing with X, Y, and R. That's all I've done is change letters. Here's my angle theta. This is the adjacent side to theta. This is the opposite side to theta. And there is your hypotenuse. So in terms of X, Y, and R, if I ask you to write the sine of theta, what would you get? Remember, sine is opposite over hypotenuse. The opposite side in the plane is y. The hypotenuse is r. Let's look at cosine of theta. Cosine was adjacent over hypotenuse. The adjacent side now is a distance of x, and the hypotenuse is the radius of that circle, r. The tangent of our angle measure theta is opposite over adjacent. Here is what I want you to be able to do. Using x, y, and r, I want you to be able to come up with the 6 trig ratios. Now, cosecant is the cofunction, a reciprocal relationship, cofunction with the sine function of our angle theta. So we know that's r over y. Secant is the reciprocal cofunction for cosine. That's r over x. And cotangent is the reciprocal cofunction to tangent. That's x over y. So there's the 6 basic trig functions put into the xy plane, because that's where we're going to live this year. And so we understand that if we were to put a right triangle in the plane with one of the acute angles centered at the point of origin, with the right angle sitting on the horizontal axis, and the other angle just up in the plane resting at a point, the point xy, that we can talk about the trig functions that are true for that angle measure theta. That's all I want you to see as far as that is concerned. And you can see here are the 6 relationships we just came up with. So make sure that you could do that. And understand that all of this is according to whatever angle measure theta is. And so what we're going to do next is we're going to talk about exact values, and we're going to pick angle measures for theta and see what x, y, and r happen to be. So look for that next video. We want to talk about exact values.